The topic for today is rational inequality. I'm going to explain to you how to solve the inequality with the rational expressions. And I'm going to teach you how to solve these inequalities using many examples. This is my first example. The first step to find the solution of this inequality, you need to find what is the LCD, what is the least common denominator. In this case, the least common denominator is x minus 6, is x minus 6 and x plus 1. X minus 6 times x plus 1. And now using this expression, you find, using the LCD, you add these two rational expressions. What are you doing? Using this, you add these two expressions using the LCD. And now, after that, you do distributive property, combined term, and this is my new inequality expressions. Now, next step, you need to find the zeros of these rational functions. To find the zero, the numerator have to be equal to 0. And solving these equations, the zero is 4/3. This is the zero. Now, when you have the equation, final equations, you find the zero and you find the undefined points. The undefined point, to find the undefined points, you use the two denominators, the two factors in the denominator, x minus 6 equals 0 and x plus 1 equals 0. And solve these two equations. And now, the undefined value of the x is s equals 6 and x equals -1. Using these three numbers, the 0 and undefined point, you create this real line. -1, 4/3, and 6. When you create this line, you create this table. And you write on the table, the column of the tables are formed by the three factors. This one is 6 minus a, x minus 6, and x plus 1, x plus 1. Now, in the first column, in this column, you write the interval, and you get the interval from this line, from this line. The first interval is here from negative infinity to -1, because the equation here do not have no equal sign here. Then you not consider 4/3 close, because it's not include 0. Now another interval is from -1 to 4/3. It's another interval. And the last interval is from 4/3 to 6. That's a 3 interval. -1, negative infinity to 1, -1 to 4/3, 4/3 to 6, and 3 to 6 to positive infinity. And you select in each interval one numbers. For example, in this interval, I select -2. In this interval, I select 0. In this interval, in this interval, I select 2, -2. Here, 0. Here, select 2, and here, 7. And you plug in, substitute the x in this column by the corresponding number, and you find the sign. For example, -2 times 6 is -12, minus 8 is -20, is negative, and you continue to do the same things in each term. And now You multiply negative 6 times negative 6 is positive, times negative is going to be negative. And you do the same thing with another column with another corresponding value. You do the same thing, you use the number. Okay? For example, in the 7 times 6 minus 8 is positive. I'm going to do this example. For example, you use 7. 7 times 6 minus 8 is positive. 7 minus 6 is positive. 7 plus 1 is positive. And a positive times positive, this positive times positive, its denominator is positive, and a positive divided times the positive is positive. But my equation, I need to find when this expression is greater than 0, when it is positive. Now, my solution is positive here, my corresponding interval is this and this one, and now my final solution is from negative 4/3 union with this another interval, 6, positive infinite. This is the first example how to find the solution of rational inequality. Another example. I have another example. Corresponding here, you create the graph, in the graph here. Okay. Next. Now, I have another inequality. By another inequality here, this is another inequality. The same step is the same step. Find the LCD. You added the two rational expressions using the LCD. You do the multiplication now. You combine the term, combine the terms, and I have now this is my new rationals inequality. One factor on the 0 is numerator equals 0. This is the solution. Then the fine point is when the factors of the denominators is 0. You create the line. But now, because this is included here, because 9/5 is a 0, because the equation includes the equal sign. Now, because the equation includes the equal sign, this is include here the equal sign, and the 0 is this one. This is the 0. I need to close. They have to be shared because it's closed. And now, with the same thing in the exercise before to this one, you create a table. The first column is the numerator. Second two column is the two factors in the denominator. The first line, the first row is the interval from negative infinity to 7, negative 7 to 2, 2/19/5. You see I use bracket because you need to include it. And you substitute, you select each number, you select one number for each interval, you plug in the corresponding column, and we do the same thing from the exercise before. The exercise before is like this. You substitute to find the sign of each interval corresponding to each expression. Because the equation is, the rational inequality is how when this a rational function is greater than or equal to 0, I'm going to consider only the positive. I use only the positive. This is the positive interval, and this is another interval when the function is positive. Now the final solution is negative infinity to 7 union 2 19/5 included 19/5 because I have include here, you see here, I include here equal 0. You need to use bracket. Next example. Now using the graph, you put this interval on the graph from negative infinity to 0. It's here. This is from negative infinity to 0. And this is the interval 2 to 19/5. And you plug in, you represent the solution of inequality graphically. Next problem. Now in the denominator, I have quadratic equation. Then the first step is select the quadratic equation and do the factorization. This is a thematic of algebra 2. You find the factorization. Now my new inequality is this one. From this point, you continue to do the same step I did in the two examples before. You find the 0 is x equal to, the undefined point is when the denominator is 0, negative 4 and 3. You create the line including negative 2, because negative 2 is a 0. You create a table with the corresponding interval. You find the signs. You find the signs in this case. In this case, you find the sign of each interval using 1 point. For example, in this interval, I use in the first, this interval, I use negative 5. Negative 5 is in the interval negative infinity to negative 4. Negative 3 in this interval. 0 in this interval. 4. And you plug in the corresponding value in each these expressions and you find the sign. And now you multiply the sign. Negative times negative times negative, negative. Negative times positive times negative is positive. Positive times positive. And the question is here, you come back to the equation. You come back to my inequality. And the equation is less than equal 0. Then my solution is the negative sign. Negative and negative. The corresponding interval is this. And another corresponding interval is this. My final solution is negative infinity to negative 4, union negative 2 to 3. And I'm going to recommend this always. When there are quadratic functions in the problems, the first step is to perform the factorization. Always, when the problem involves quadratic expressions, the first step is find the factorization, perform the factorization. Thank you very much for watching this video. I'll see you in another video. Thank you very much.